Test.
First off, we stop writing malware, so the blue team has done it for you. Presented by Alberto Rodriguez and Erik Hunstad.
Thanks. This is Stop Writing Malware. The blue team has done it for you. By the time I finish this sentence, over 200 unique binary samples will have been submitted to VirusTotal. This is your real enemy if you're an offensive security practitioner. It's warehouses full of servers, running machine learning algorithms, doing all these detections against your binary, trying to determine, is it malicious or not? But what if I told you that there was a way that you could bypass all of this? Instead of getting your code run through these warehouses of machines, you could get a green stamp, a check mark, a lock icon that says, this is trusted, we don't need to do any more analysis. That's what we're going to talk about today in this talk. So my name is Erik Hunstad. I'm the CTO at 6Gen, a cybersecurity consulting firm out of Annapolis, Maryland. I'm also the adversary simulation lead, and I run that team. I'm on Twitter as Bad Sector Labs, and I run a weekly blog where I scroll through Twitter and find the interesting things so that you don't have to.
Hey, good morning, everyone. Alberto Rodriguez. I work at PayPal doing cybery things, and you can find me on Twitter as well. And yeah, I hope you guys enjoy this talk. It'll be great.
All right, so today we're going to go through the state of offensive security tooling. This is everything from remote access tools to actions on objective tools, your memory dumpers, things like that. We're going to talk about how these tools are getting detected. We'll talk about how people are starting to write their own C2s and what that entails. We'll introduce a concept called Traderware, and then we'll round it out with some detection ideas to help the blue team out. All right, so offensive security tools. A lot of you guys know these. Everything from your Cobalt Strike, probably the most popular, but there are a bunch of commercial tools that you can go out and buy that will give you remote access to systems as long as you run a binary or load something in memory. Those are the commercial offensive security tools, a lot of names up here. And then there are open source versions of these same things. They accomplish the same goals, and there's so many of these frameworks, too many to list on a slide. We've got some logos up of some of our favorites. But this is kind of the space that we're talking about with offensive security tools. These are becoming more and more detected every day. There are known signatures. If you just download the latest open source C2 framework off of GitHub, it's going to get detected as soon as it hits disk from Defender or whatever EDR that you're running. And that's a good thing. It should be. There are also advanced signaturing and fingerprinting techniques like JARM and JA3, JA3S. These will actually scan a server, determine its TLS stack, and then see if that matches a known fingerprint of an offensive security tool or a team server or something like that. Then people have written these rules like you see in the pictures here where they're looking specifically for those names. You saw in the keynote, Travis Ormandy's name is now a signature for malware. And likewise, some of these authors are also being detected. And then on the right side, I just did a CodeQL search for Cobalt Strike YAR rules on GitHub and had thousands of hits. So there are specific YAR rules looking just for specific commercial open source security tools and commercial security tools. And this is only getting more and more intense. So you can see this graph is going to the moon. Everyone is scanning for Cobalt Strike and these offensive security tools. So if you're using one of these, know that you are becoming kind of a target for the blue team and the offensive blue teams. And cyber threat intelligence is confirming this. Cobalt Strike, by almost 10 times more than any other tool, is being used by actual adversaries. So the adversary simulation tool is now becoming the actual adversary tool, having become a self-fulfilling prophecy, perhaps. There's also other open source tools, Mythic, Covenant, and Sliver were used in 2021 for actual adversary attacks on companies to deploy ransomware. So you can see the table on the bottom shows how many attacks we're using those tools. And basically, if you can stop using Cobalt Strike or those tools, maybe you'll get around some of those detections. So naturally, what does everyone think? Well, fine, if those are getting detected, I'll just write my own. How hard could it be? There are tons of open source C2 frameworks. The last time I checked, there were 97 on this website called the C2 Matrix that attempts to track them all. But there was even one released called Havoc Framework just yesterday. So they're constantly coming out. Everyone thinks that, well, easy, I'll just write my own C2. they don't take into consideration how difficult it's going to be to maintain these things. Dominic Schell here is with MDSec, who released the Nighthawk commercial OST, and he said it was a full-time job just to do the QA testing. So imagine you've got to make your C2 framework work not only on your test box, but also on every box that you could encounter in a customer environment. So your old Windows 7 machines, maybe even a Windows XP machine, is it going to cause problems on that? It was a full-time job for a year and a half for 2 people working full-time for Dominic. So today we're going to say, that's maybe not the way to go. What about this thing called Traderware? So what if we take software that's already developed to be stable, cross-platform, work on everything, it's already trusted in the environment, and what if we turn that and use that for red team goals? So Traderware is software that betrays the trust placed in it to perform these malicious actions. And it's going to allow you to do your red teams without those detections. This isn't a new concept. We're not that novel. It's been around for a while. This is one of my favorite tweets that says the only difference between an antivirus and a rootkit is the malicious intent. And today I think we're going to show that that is very true. But first, to get a feel of what the blue team is working with, I'll hand it off to Alberto to talk through that.
All right, all right. You guys hear me okay in the back? Thumbs up? Cool. I'm going to keep my water just because my throat's a little itchy. I'm from Florida, and in case you didn't know, it's been raining there a little bit. So yeah, fun times. All right, cool. So defensive primer, right? You know, we're familiar with these tools like SIM, EDR, XDR, whatever, right? We have these telemetry enhancers such as Sysmon, et cetera, that can collect better data for us to enable our security operations, right? We're all familiar with these tools, and usually we deploy them in our environment to get better visibility, better actions on the defensive posture that we're trying to get at. So we've all seen this life cycle from an attacker perspective. This is yet another one of those. We just wanted to map what sort of software solutions are what's the term? English is evading me. Involved, there we go, thank you. Involved in each of the phases, right? So you have, you know, the reconnaissance phase, privilege escalation, et cetera. I'm not going to sit here and talk through all of these vendors, but the point we're trying to make with this slide is there's a way to do a phase of the operation with known trusted software, vendors, et cetera, okay? And I just want to quickly focus on the end there, exfiltration and complete mission. You know, the concept of exfiltrating data and getting your objectives out of the environment from, I don't know, OneDrive as an example, is becoming more and more of de facto to be successful, right? So keep that in mind if you're a security analyst monitoring your network. When you see a lot of OneDrive traffic coming in, it might not necessarily be what you think it is. So for recon, right? I love that meme. It's great. Okay, anyone familiar with Rocket Reach? Salespeople, raise your hand. Boom, it's great. Unfortunately, though, the free tier sucks. I think you get like 5 only. So test it out if you're a red teamer. But you can get quite a bit of information if you target an individual from Rocket Reach. Excellent platform. We have ChartLoop. This was not modified whatsoever. Your targets, yes. All right, you can map your targets out with this type of software. Again, we have a lot to go through, so I'm not going to discuss every detail of the software itself, but definitely check it out. Finding assets, we're all familiar with things like Shodan, Zoomeye, et cetera. There's 1,000,001 tools out there that you can perform your recon without you having to, again, build your own, which is the whole intent of this conversation. Attack surface mapping software. Spiderfoot's been around for a long time. It's open source. You plug in one domain, you click go, you go get coffee, and then you get sidetracked because your kid's, you know, on top of the Roomba all of a sudden. And you come back and you have a plethora of data around your target infrastructure. You didn't have to code this yourself. It's readily accessible for you. I'm going to turn things over to Erik so we can discuss initial access.
All right, so once you find your targets, you got them on Rocket Reach, you send them some emails, how are you going to get initial access into that machine? This is normally where you'd write a custom loader trying to get around the EDR that's maybe on that desktop, or you've got to convince them to install some app that you wrote, again, trying to bypass EDR. What if you just gave them a link to Chrome Remote Desktop and said, hey, I'm from IT and I need to install something, it's a priority, click here and give me access. Chrome Remote Desktop is already a trusted piece of software, 0 out of 72 on VirusTotal. Why are you trying so hard to evade EDR if you can just use what's already out there? Or Chrome extensions. This one's a little trickier. If you can get them onto disk, there's a way that you can load them with the --load-extensions flag, where it will load a unpacked extension and won't even tell the user. So you won't get a prompt, you won't get developer mode or anything like that, and all of a sudden you now have a hook into that user's browser. And as things become more SaaS heavy, everyone's doing everything through a web app, maybe you only need access to their browser to accomplish your mission. It's not always about trying to get domain admin. If their valuable information is in their browser, that's where you want to be. Another thing, if you've ever run an installer, 50% of the time it's going to be made by this open source tool called InnoSetup. And this is what creates that dialog box that you have to click through. You know, do you want to install it in program files and all that kind of menu. There was a POC that came out where a gentleman figured out how to run shellcode inside of this setup window. So you can just put your payload directly into your setup wizard, and the EDRs aren't looking at what's happening in the setup wizard because they do all kinds of crazy things. So you get very low detection rates, and the user is familiar with clicking through this and has already been trained to click through these dialogues and give you access, basically. So once you have access to a machine, you want to stay there, right? You've earned your access. We'll come back to persistence. This is going to be the heavy point of this talk. Once you're persisted on a machine, it's time to look around and see what else is around and how you can move to those other machines. The default for this one is Bloodhound. I'm sure any offensive person in the room who's been in an internal network has used Bloodhound to map out the network. It's a great tool. But what if it was signed? What if it was trusted? What if the organization saw something running instead of SharpHound as malware, SharpHound as, oh, we know that that's a good defensive tool? Well, there's Bloodhound Enterprise, the new product from SpecterOps, and it comes with an enterprise version of SharpHound, the collector that gathers all this data. So if you can get yourself a copy of Bloodhound Enterprise, perhaps that trusted version of SharpHound will get you your data without any detections. There's also a product called PingCastle. Mapping AD for attack paths is not just an offensive thing. The defenders want to do it too, so let's use their tools to do that. PingCastle is another product that will do that for you. It'll give you a nice attack map. Again, these binaries might be trusted in the environment that you're targeting. And then, of course, all the big vendors had to join in. AD Managed Plus, Tenable has their own, etc. If you get access, especially if the blue team is already running these products, if you get access and just log into their big database of all their machines, you already have that data and you don't need to collect it yourself in a way that could be detected. This is one of my favorite products. It's called Run0. It used to be called Rumble Run. It's made by the guy that wrote Metasploit. Excellent tool for finding shadow IT. And what shadow IT is that Windows 2012 box that you set up 10 years ago to test out that one web app or something and then you forgot about, and it's still running off in the side and not being patched and could be vulnerable to who knows what. So this is a great scanner that you can run once you're inside a network or even outside a network to try and find just all the assets, fingerprint everything, basically tell me what's on this network and where could I possibly go. This is a great tool. Once you get to a target that you need to do something more on, you've got to do some actions on target.
All right. So again, onto the theme with trusted binaries, trusted everything, right? Microsoft Visual Studio has these nifty, and I had to double check with Eric. I asked him like 5 times, how to validate. Is it really called inject DLL AMD64.exe being used by Microsoft Visual Studio? He's like, yes, 100%. And in fact, it is, right? So you can actually inject the DLL using a Microsoft signed binary that is called inject DLL. I mean, that just blew my mind, right? Driver abuse. Again, Process Explorer. There's a tool that weaponizes this, but for a little bit, there was a driver that Process Explorer you can leverage to kill EDR or AD products in the environment. So now you can tamper with security products, leveraging, again, Microsoft signed binaries. And I'm sure if you go hunting for these, there's going to be more. Here's another one, Process Hacker. Everyone here use Process Hacker? Show of hands. Yeah, great tool. Again, driver abuse. Signed binary runners. We used RedJSM as red teamers for a long time, right? Everyone used RedJSM, and then MS Build. All these things were getting caught, so now boom, PyCharm, runner W.exe. You can execute code using using partial executables, which are, again, signed as well. There at the bottom, default pack.exe. There's tons of these living off the land binaries, which you can leverage. They're signed. You can leverage to execute your malicious code that you need. Signed memory dumpers, right? Mimikatz, everyone's familiar with that tool, Benjamin Delpy, etc. Instead of dumping, memory, process from memory using Mimikatz, why don't we use Steam binaries? Everyone here a gamer? Use Steam? Yeah, there's a little, you can't really tell, but there's a binary in the Steam installation which allows you to dump a PID's memory. Wicked. You can use your gaming rigs to do some hacking now as well. Obviously, ABAS. I think that's kind of a given. Everyone knew ABAS has some memory dumping capabilities. Well, guess what? Not only if you land in an environment that has ABAS, can you leverage that capability, but you can just bring it along, right? You can just, upload the binary yourself. It's already signed. It's probably not going to get caught. This is very similar to the tactic that the folks who did the SolarWinds hack leverage. They brought like their own version of a Windows Defender DLL, which was vulnerable, and then they leveraged it in their operations. So again, attackers are leveraging these, known goods, so to speak. For data exfiltration, again, something I talked about in the beginning. Please, if you have your notepad, write this down. There's this site called Living Off the Land Trusted Sites, LOTS. We have LOL bins, LOL baths, LOL everything. Even the LOL dolls I'm buying for my daughter. But now we have LOTS, okay, which is all these awesome sites that will allow you to exfiltrate data, legitimately, quote unquote, right? I'm talking OneDrive, Cloudflare, Google Drive, Google Sheets API. Anyone here use the Google Sheets API to tunnel their C2? Yeah, it's great. People think you're doing work, but technically you are. People think that employee is doing work. Man, they're all over Google Drive today. Yeah, it's the attacker exfiltrated data. So that's a method of getting rid of your data out of the network without essentially tipping your hand off with some custom domain that you cooked up for 60 days, right? So now, here's kind of the big chunk of the talk. I'm going to turn things over to Erik so we can talk about persistence.
Right, so we're focused on persistence today, and we're going to introduce what we call the OSquery suite. So this is how we use blue team or sysadmin tools to perform our command and control. We're going to reduce your development efforts, so instead of you doing all the QA and testing to get your software to work on every version of Windows, plus Linux, plus Mac OS, make it stable, every update, you've got to have some crazy CI pipeline. Instead, we're going to use tools that are already doing that for us. So we're using these trusted and signed binaries within these tools to execute our code, and this is going to minimize your detections and make it even easier. To start off with, we'll talk about Splunk.
All right, show of hands. Who's used Splunk? Or at least know what Splunk is, right? It's a pretty popular SIM. It's like super cheap. You can get it, for the low. It's great. So Splunk, right? In case you didn't know what Splunk was, you have an agent component, and then you have like a plethora of server components, so to speak. And that server components that can be search head, indexers, deployment servers, which we're going to talk about, right? As a deployment server, that allows you to centrally manage what you get the agents to do, okay? Then you have your deployment client, which is really the agent side of things. So, okay, we got this deployment server over here. We got this client over here. They kind of talk to each other. This one sends commands to the other. You can see where I'm going with this. And then you have a deployment app. That app is kind of like the package deal where the deployment server, right, tells the client, hey, buddy, you're going to get this app. And that app is going to contain things for you to do. Execute scripts, load some stuff, right? You see where I'm going with this? Splunk as a C2, why not, right? Why do I have to go build a custom loader, pay some exploit dev to do some fancy stuff? Just kidding, keep doing that, it's great. A lot of technical work, which is hard. Let's be real. If you're out here trying to evade, the Sentinel-1s, CrowdStrikes, et cetera of the world, it's not like it used to be, right? You can't just roll up and change a string and call it a day most of the times. Nowadays, you have to understand those Win32 API calls and really understand the EDR to evade them. So let's use Splunk as our C2, right? We're going to use, obviously, the server as our server side, which comes with a great UI, by the way. Has dark mode for those that like that. And it comes with an agent side, which is the official Splunk universal forwarder for the Splunk folks in the room. There has been some prior research done by this in the past, so I'll link some of those in our GitLab when we release the project, which I think it's already out. So on the server side, easy enough. I'm not a Splunk engineer, so if you're a Splunk engineer, you're like, oh, this is so manual. I hear you. Just bear with me. All right. You're going to configure it to receive data, and then you're going to set it up as a deployment server. Boom, done. Awesome. On the agent side, this is my implant, right? Awesome. We're going to install the agent. We're going to set it up to be a deployment client. You know, these are Splunk terms. We're going to change the service name, which you can do in Splunk. That's awesome, right? A little OPSEC consideration built in. Nice touch. So we can change the service name. We can enable it on reboot. There's that persist side of things. And then do the TLS, change the ports, et cetera, et cetera. Okay, this is kind of how it looks, the command line side of things. Again, you can modify that service name to make it OPSEC friendly, which is great. And at the end of the day, we're going to have a C2 framework over HTTPS, cross-platform. It's going to support all your different operating systems that you might need to have access to. You can task it remotely, and it's all signed binaries, right? And then you may say, hey, okay, signed binaries, like what else? Well, VirusTotal, things are pretty cool as well, right? No detections whatsoever. I'm talking Splunk.exe, Splunkd.exe, Splunk-WMI.exe, more on that later, and then Splunk-PowerShell.exe, again, all signed by Splunk, all are Gucci per VirusTotal. Awesome. What does Cisco have to say about this? And I'm not picking on Cisco. If you work for Cisco, if you're listening, I'm poor. Cisco, you know, they have these exclusion lists on their EDR. I think it's called AMP, right? Something like that. Cisco AMP. So they exclude Splunk binaries from triggering their alerts, right? Like you need Splunk to work in most environments. So sorry, Cisco, but thanks for proving the point a little bit. Worth mentioning, about June of this year, there was a CVE that came out. That was like, I think it was a 9 point something on the criticality scale. It was 2 days after this talk got rejected by DEF CON, by the way. I'm just saying. So 2 days after we received our rejection, this CVE came out. And the CVE was super interesting because essentially, if a user compromised a deployment client, one universal forwarder, there was a way to compromise every single deployment client that married with that deployment server through Splunk apps. So again, I don't know if there's like a coincidence or anything like that, but this came out shortly after. It just goes to show that the trust that we give to these security products are something to keep in mind when you're doing your, don't kill me for this, your threat modeling. I know, buzzword. But when you're threat modeling in your environment, you should now be bringing this sort of Traderware into the conversations and into the tabletop exercises. So, have a little demo for you. Let me go ahead and stand behind. Cool. On the top, we have Splunk. Sorry, no dark mode. On the bottom, I have the Splunk server. So that's the CLI, okay? So I have an agent installed, and there's the version. I pulled it up pretty new. I did this like a week ago, even though the talk, we've been working on it for a little bit. I go on interact mode. All this code will be available for you. So there's a quick IP config. Now at the same time, you see the Splunk app is being sent to the client. There it is, Splunk C2 app. Obviously, pick a OPSEC-friendly name. That is written. A bunch of things will happen there at the top, a little Splunk exe action going on, awesome, cool, and then you can come back to the UI, and then you have your output. That's a pretty nice C2 framework, right? Just like the standard stuff. I mean, we're not hating. You can determine what source type you have. You can organize it by the source as well. So if you want to do fancy dashboarding, you can as well. There's my quick mandatory echo statement into the desktop, just so you know. Obviously, there's code execution taking place. So I'm writing Splunking, and here I'm getting ready to show you. So it comes with a full same capability, right? I can put a whole bunch of deployment clients in one server class, so I can essentially execute code in the masses. I can group them together. Maybe I want to target the workstations differently than the servers for lateral movement. And here in the last piece, the WMI POC. So for the WMI, I'm going to pause it here for a second. This is a Splunk-WMI.exe. It's an executable signed by Splunk, et cetera, that will execute WMI query language syntax, okay? Which is great. I mean, you can do a lot with WMI. Anyone here mess around with WMI? Yeah. So full WMI stuff, I'm game for it. And let me just fast forward it here as well. And I have the syntax. There you can see WMI.exe is going to pop up on the top here. Boom, signed. Again, VirusTotal has nothing to say about this. This is great. I don't think your EDRs are going to scream too much at Splunk because then there'd be like trouble in paradise on the vendor department. And I'll pause it here again. There you can see the queries. Everyone here familiar with like WMIC, get object, dash, WQL, select star from Win32 process or user account or computer system, etc. So you can perform your entire enumeration through WMI, which again, that's pretty awesome. And it's going to be performed by a signed executable from Splunk. So, I mean, and hey, I'm not a Splunk, wizard, but I'm pretty sure I can do some fancy dashboarding too, right? And make it look really nice. So I didn't play around with that capability of the SIM, but a gut tells me that, it'll be good for your ops if you do some dashboarding as well. So that was Splunk. Okay, again, the code that we used is going to be readily accessible. I think you can Google it now. There'll be a QR code at the end. You can trust us. All right. Just the final piece I want to hit on before I turn things over to the next product we weaponize. EDRs, XDRs, that whole shebang, right? That could be a whole talk on its own. I'm talking the SentinelOnes, the CrowdStrikes, all those folks that have RCE on your endpoints, right? We all know about it, and it kind of like, we openly joke about it at work, but really, hold the vendors accountable to providing those artifacts to understand what's good and what's not good, within the realm of possibility from their products, right? What is the baseline? What is the parent-to-child relationships? What's really supposed to happen? A lot of these EDR, XDR tools, full-fledged software suite, right? You have RBAC, right? You have all the dashboarding, all the reporting. The code execution, obviously, it'll be a plus. And a lot of the times when you have multiple EDRs, it used to be back in the days, they fought each other, right? Anyone here, you installed one EDR and they started fighting each other? I think nowadays they don't really fight too much. I don't know, my experience, especially when I was a consultant, I would install things on top of each other and I didn't have too many issues like I used to back in the days, right? So keep that in mind because an attacker can bring in some of these software tools like an EDR. Anyone here familiar with the Ateras of the world, right? RMMs, Zabbix, all these jokers? Well, they can bring them into the environment and it can really cause havoc into your infrastructure. There's a obligatory Twitter post from Rastamouse himself. Elastic recently announced that they have an EDR capability that allows you to code execution, et cetera, et cetera. So obviously, red teamers on Twitter are like, cool, another RCE tool, right? Another C2 framework. So turn things over for some OSquery.
All right, so we got the Splunk, we talked about EDRs. There's another tool called OSquery. You might not have heard about this one. It started at Facebook, which is now Meta. They turned it over to the Linux Foundation, but what it lets you do is write SQL-like queries against any computer that has an OSquery agent installed on it. So if you're familiar with SQL syntax, you can do your selects, you can do joins, where clauses, all that kind of stuff to look at information about your endpoints. Facebook used it to just monitor their entire fleet of servers as well as their workstation endpoints. And it's really powerful. It's a great tool, but it's also signed, and it comes from a trusted source, and it's whitelisted on VirusTotal. So obviously, we're going to see what can we do with it. On the left side, you'll see that's an example query where it's just looking for, show me all the processes that are listening globally on an endpoint, and give me their name, the port, and the PID. So that's kind of an example of what you can do with OSquery. On the right side, you'll see there are many open source as well as commercial dashboards. This one's called Fleet, and you can get a web interface as well as a command line interface to query your endpoints from. All right, so on the left side, I've installed Fleet, and I'm connected to one of my test endpoints. You'll see it has a lot of things like disk space, the status, the last check-in, the first check-in, your agent options, how long it takes to call in, the TLS options. Sounds a lot like a C2 if you ask me. There's no difference here between an offensive tool and what we're seeing with OSquery. On the right side, there's an example query that I did in the web interface, and it just shows you the power. It's tying the process and the PID and the process name to the listening port so you can combine all that data. And so that's how you would use it normally. So to recap OSquery, it has no noticeable artifacts. It installs as a service. So if you put it on a machine, the user isn't going to get a tray icon or a pop-up or anything like that. It installs in the background. It communicates over HTTPS, so everything's encrypted. It's cross-platform across all 3 major OSs. You can task it remotely either through the command line or the web interface. The binary is signed by a senior software engineer at Meta. And it does signed automatic updates so you can keep your agent up to date with the latest features. It also supports this thing called extensions. And so that is very interesting, and we're going to get into that today with Iscariot OSquery. And that's our extension for OSquery that we wrote. It's written in Go, and it allows you to execute binaries directly, execute shell commands with a full shell environment. It can run unmodified Cobalt Strike BOFs. If you've used Cobalt Strike, there's a module structure called a beacon object file, or BOF, that allows you to directly access the Windows API through your process, so you're not spawning or forking or doing anything like that. It also runs C# assemblies directly in memory in your same process space. So it will load the CLR and actually run those binaries for you. And it patches ETW and AMSI, so you won't get caught. So here's an example query of us querying whoami/priv with ushell equals 0. So that means we're just going to run the whoami.exe binary directly, give us that output, and put it in a SQL table. It's a little user unfriendly with the output because you have to return an element for each row in the column. So that's why you see a lot of repeats. But don't worry, we've cleaned this up into a nice shell for you. You can also execute shell commands with full shell environment. So this is going to actually spawn cmd.exe and allow you to go into environment variables. You can pipe commands together. All the things that you would normally do in a shell, you can now do through OSquery. And these shell processes are going to be child processes of your signed binary from Meta, which is great. Cobalt Strike BOFs. So if you want to get a little more advanced with your tradecraft and you want to do some low-level Win32 API calls, now you don't have to write your own low-level C code for Windows. You can take what's off of GitHub. People have already pre-compiled these Cobalt Strike BOFs, and you can run them through OSquery. And so this is an example of just a simple one that's getting the ARP table from a Windows machine. And again, this is not forking or running any processes. It's directly inside that process space calling those Windows APIs. You can even pass arguments to these BOFs. It's a little bit dirty right now, especially in the query syntax. You have to know the type of the argument and pass it in that way, but it is possible to give arguments to the BOFs. All right, let's see a demo. All right, there's no tricks up my sleeve. Antivirus is on, so the latest Windows Defender on Windows 11 Enterprise. I did turn off cloud delivery and automatic sample submission so that Microsoft doesn't get all my stuff right away. On the left side, you'll see the Iscariot process is running as a child of OSquery D, and so that's our signed process OSquery D, and then our extension is running as a child of that. I'm SSH'd in to the Fleet server, so this is the control server for all my OSquery agents, and I'm going to run our client that we wrote. First, it's going to give us the hosts that are currently connected to this system. Right now, we've only got one, our Windows 11 test machine. That's the one you can see in the background on the left. It's going to ask us what we want to operate on, and then give us 4 options of how we want to do it. That's the 4 options I just went through. So to start off with, we'll execute a shell command. And to demonstrate the full power of the shell, I will pipe a task list into a find stir so you can chain multiple commands together, and we'll see who's running a CMD on this box. After a little bit, it comes back, and we see the user that's already P'd in has a couple shells open, and then there's us at the bottom running as services, and we have a CMD to run this command chain. If we go back, we can execute EXEs directly without spawning a CMD. And so this time I'm going to do that same whoami/priv, and this will task the agent to just run that EXE directly and then give us the output back in a nice format. It was a little too quick to see on the left side, but it did actually spawn that EXE and give us the output. Next, we'll run a BOF. In this case, I'm going to run the ARP BOF, the same one that we did in the slides. This won't spawn any processes. It's going to directly call those APIs within our process context and give us the output back. And these will, you can run any Cobalt Strike bot without modification. They work out of the box. Same thing with C# assemblies. So here I'm going to run seatbelt with just the antivirus function of that to display the antivirus on this machine. This is going to patch event tracing for Windows, as well as the anti-malware scan interface. So you're not going to get detected by AMSI or any product that's using ETW. This is a stock seatbelt directly off of GitHub, no modifications. So you don't need to change anything about your existing C# tooling to use it in OSquery with Iscariot. All right, as we start to wrap up, what can we do about this and what does it do to help us? So we talked about how people have gone to creating their own C2s to try and get around the massive amounts of detections there are for Cobalt Strike and other similar commercial and open source C2s. Unfortunately, if you're a red teamer, it's hard to find time to do this that you can justify as a billable hour for a client if you're on an engagement. When you go to an engagement, they expect you to have a tool set that's going to be able to perform the objectives and help them get better at security. So oftentimes people are doing this after hours, or it's on overhead time, and it's tough to find a way to cover these costs. So if you're not a boutique red team shop, it could be difficult to get a high quality C2 that works across versions and things like that. Also, the barrier to entry to writing your own C2 these days is very high. Back in the day, you could take a command, run it through base64, and then decode it on target and run it in memory, and you'd be okay. It doesn't fly anymore. The EDRs have gotten very good, and the AI, ML, blockchain, whatever voodoo, plus some big data, it's actually pretty good. So it takes a lot of low-level knowledge. You're going to be writing assembly. You've got to know the Win32 API in order to get around these EDRs. So our dream with the Iscariot suite is we want to shift some power back to the red teams and say, you should be focusing on making meaningful change to your customers instead of how do I bypass this one EDR for this assessment. So let's focus on the bigger, more impactful changes instead of the cat and mouse game of get around an EDR.
All right. So again, this is kind of a message to vendors, right? If you're a vendor out there, we just want to say, do your best. We understand hours are limited, et cetera. Do your best to provide your customers with that deep technical knowledge of what your product does and what it can and cannot do, right? I'm talking parent-to-child process relationships, how you're writing the service, on that operating system, how you're, persisting on that system, whether it's a register key or a scheduled task, et cetera. Provide your customer with all this technical information so they can build detections around those specific products, okay? If you are a customer that doesn't use any of these, then you should be, hopefully your vendor can help you, your existing products can help you with some of this, but if you don't have that from your vendors and your security products, you should also be building out detections and preventions against Splunk, right? If you don't have Splunk, then look for it, right? If you don't have OSquery, go and look for it, okay? We want to ensure that everyone, from today on, in case you didn't know, I'm sure many of you did know, that you're tracking all the capabilities of the many, many security products that are out there, and you find a way to prevent or detect them in your environment, especially if you're not using them, right? Because we've all had this connotation in security, especially on the blue team side, and I remember when I was a blue teamer as well, that, it'd be horrible if somebody gained access to our Splunk cluster. Okay, yes, that makes sense. But what if that's not your Splunk cluster? They're just hosting it on AWS, your attacker is, and they're using Splunk to do their entire operation, right? It's a different bit, it's a bit of a twist as our conversation before, whether it goes from we need to defend our defensive posture. Yes, you still need to do that because if they pwn that, then you're still done. But now we're also going to have to detect and prevent against these security products that are not in our environment, okay? And that's kind of the messaging with this specific talk is try to alert for, try to prepare for Traderware. There might be an official term for it. We think Traderware makes sense. And yeah, it just made sense. So We've got many references for this talk. This talk started as like a conversation between Erik and I probably 2 years, right? Where we were just like, yeah, like Sentinel-1, RCE, cool. And we just kept bickering about it. And then we're like, you know what? We're going to make a talk about how Traderware can really be a security implication to the industry as a whole. So there's a ton of references that'll be on the GitLab repo, previous conferences, previous white papers, etc. You can find them all here. There's a lot of people to thank for as well, because we obviously pulled some code from the internet. We're not in the business of writing and reinventing the wheel, in case you didn't notice. So we definitely want to give a shout out to those folks. They're at the bottom. Definitely check out that LOTS project. Personally speaking, I think that's going to be pretty big coming up, especially in your detection engineering efforts, where you have pretty much legitimate traffic always leaving your environment, and you're not going to know which one's which. And especially when TLS 1.3 is like widely adopted, and they do some security heightening on that effort as well. So here's our contact information. Erik over there, A-Rod over here. QR code to the GitLab link, so you can check out the code. You can check out these slides, which I think are up as well. If not, we'll get them up there as a PDF for you. So you can maybe dish it out to your coworkers, etc. And you can follow us on the socials. There's Twitter, LinkedIn, etc. Thank you guys for your attention and your dedication. Thank you guys for being here, and I hope you have a great rest of your day. Oh, before I forget, I was probably going to get